Yes, come in. Oh, you have got some prize. Very nice.
Ma'am.
Oh, beautiful cups. Very big and very nice. This is the first prize.
Yes, ma'am.
Yeah, really good. I am very happy.
Thank you, ma'am.
And as I told you over the phone when you informed me, I told you I expected it. Right? I am telling you again, I did expect that you would win a prize.
So
And
nice
that's
of
too
you,
a
ma'am.
first prize. And you have done it. Wish you all the best
Thank
in
you, ma'am.
everything.
Thank you, ma'am.
Yes. Yes, sit down.
Yeah. So, ma'am, you know, in like the quiz questions are very interesting and challenging also.
Yeah.
Like in one of the round, that is the most point we got. It was like they gave us 5 minutes, and we were supposed to solve the question given to us. And the full round was on calculus.
Oh, very
So
good.
we not only solved our problem, we solved another 3 problems posed to some other 3 teams, as nobody else could solve those things.
Yeah.
And we gained lot of points on that round.
Very good. So and you got a prize.
Yeah.
Yes, ma'am.
Oh, very, very nice. I am very happy and proud about you. Yeah.
Thank you, ma'am.
So you remember, ma'am, you had asked us the previous time we met to give an example of a function which is equal to its rate of change.
Yeah.
So one such function is e power x.
Yes,
Yes,
correct. You are right.
But we want to understand from your point of view, how is it that you want to talk about such a function?
Yeah.
Okay. Yeah. We will discuss about this function, but before that, I would like to discuss some more problems
Okay.
to show you that mean value theorem and Rolle's theorem have extensive applications in several situations.
Okay.
Okay, ma'am.
So, let us discuss that first, and then we will go to the discussion on the function e to the power of x.
Okay, ma'am.
So, I would like to discuss this problem first. Namely, I want you to find real numbers x such that 3 power x plus 7 power x square is 5 power x plus 5 power x square. So, I want all real numbers x which satisfy this equation. Do you see some obvious solutions?
X is equal to 0 and x is equal to 1 are definitely solutions to this problem.
Yes.
I can see another thing, like the base is like here 3 plus 7, it adds up to 10. The right side also the bases are 5 plus 5 adds up to 10. Does this has something to do here?
It is a good observation. So, that motivates us to consider the function. So, let us consider this function f of y, which is y to the power of a square plus 10 minus y to the power of a. Let me consider this function.
Okay.
I think we shall discuss about the solution. Let us go to the board and discuss about the solution.
Okay,
Okay.
ma'am. Sure.
The problem is as follows. Find all real numbers x such that you have 3 power x plus 7 power x square is 5 power x plus 5 power x square. And you had made a very nice observation, and that motivates us to consider the following function.
Okay.
F of y is y power a square plus 10 minus y to the power of a. So, if x is equal to a is a solution to our problem, 3 power x plus 7 power x square is equal to 5 power x plus 5 power x square, then what do you see about f of 5 and f of 7?
F of 5 is 5 power a squared plus 5 power a, and f of 7 is 7 power a squared plus 3 power a.
So, what do you observe?
So, like now if x is equal, a is a solution, then f of 5 and f of 7 must be equal.
Yeah,
Yes.
we have f of 5 is equal to f of 7.
Fine.
Yeah, Now we can apply the Rolle's theorem because f is a differentiable function on the interval 5, 7, on the closed interval 5, 7. F is differentiable on the closed interval 5, 7.
Fine. Yeah. Apply
So,
Rolle's theorem.
Yeah. By the Rolle's theorem, now there exists a number c such that 5 less than c less than 7
Okay.
such that f dash of c is equal to 0.
Fine.
So shall I continue from here?
Yes, please, sir.
Okay. So my function is f of y is y power a square plus 10 minus y power a.
Yes.
So f dash of c will be
A
a
square
square c power
A square
a square
minus
minus
1
1
plus
plus
A
Into
a into 10 minus c power a minus 1.
into minus 1.
There will be a negative here because minus y.
correct.
So this will be minus.
Okay.
So if f dash of c is 0, then I will get a square c power a square minus 1 minus a into 10 minus c power a minus 1. This should be 0.
Correct.
Yes.
So I can take a common,
Yes.
then it will be a c power a square minus 1 minus 10 minus c power a minus 1. That should be 0.
Yes.
So what does
So
this tell?
either a is 0,
Fine.
which we got earlier, a is 0 is a trivial
Yeah.
solution,
Yes.
or a c power a square minus 1 should be equal 10 minus c power a minus 1.
Fine. So from this, can you show that A must be positive?
Yeah, a should be positive because c is a positive number between 5 and 7. So, c power a square minus 1 anyway it will be positive.
Yes, sir.
10 minus c also this will be a positive number
Yes.
because it is less than 7.
Yes.
So, this is a positive, this is positive, hence a has to be positive.
Right.
Yes.
A has to be positive. Right. So can A be less than 1? Can A be less than 1? Think about it. Okay. Shall I give you
Yeah.
some clues?
Yes, ma'am.
Okay. So suppose 0 less than A less than 1. Then it is clear that A c to the power of a square minus 1 is less than A c to the power of a minus 1.
Yes.
Right. So if this happens, then this is true.
Yes.
Yeah.
So now I would like to make the following claim. Namely, a c to the power of a minus 1 is less than 10 minus c to the power of a minus 1.
Okay.
So I want to claim that if a lies between 0 and 1, then a c power a minus 1 is less than 10 minus c to the power of a minus 1.
Okay.
So let me write b as a minus 1.
Okay.
So a is b plus 1,
Yes.
and I would like to write my claim in terms of b. So b plus 1 into c to the power of b is less than 10 minus c to the power of b. This is what I want to show when 0 less than a less than 1 or minus 1 less than a minus 1 less than 0 or minus 1 less than b less than 0.
Yes.
So my claim is this is satisfied when b lies between minus 1 and 0.
Yes.
So as 10 minus c by c is less than 1, right, with b lying between minus 1 and 0, and remember c lies between 5 and 7.
Yes.
So 10 minus c by c to the power of b is greater than 1.
Yes.
All right, for minus 1 less than b less than 0.
Yes.
Yes.
or 10 minus c by to the power of b is greater than 1 is greater than b plus 1, because minus 1 less than b less than 0. So, b plus 1
is less than 1.
is less than 1.
Yes.
Clear? So, this tells me 10 minus c to the power of b is greater than b plus 1 into c to the power of b.
Yes.
Clear?
Yes.
So, I go back and write in terms of a.
Yeah, this is what we wanted to.
That is what we wanted to show, that b plus 1 into c to the power of b is less than 10 minus c to the power of b.
Yes.
Clear?
Yes.
Right. So, that is the claim is a c to the power of a minus 1 is less than 10 minus c power a minus 1 is what has been shown now.
Yes.
Right. So, now I consider putting all these things together. So, I start with 10 minus c power a minus 1. You have shown 10 minus c power a minus 1 is a c power a square minus 1. Right.
Yeah.
And my if 0 less than a less than 1, then this is satisfied.
Yes.
So, a c to the power of a square minus 1 is less than a c to the power of a minus 1.
Yes.
But a c power a minus 1 has been shown to be less than 10 minus c to the power of a minus 1.
Yes.
All right. So, is this possible? 10 minus c power a minus 1, right, is less than 10 minus c power a minus 1.
This
is
is
this
not
possible?
possible.
So, which is impossible,
Yes.
isn't it?
Yes.
And therefore, what is the result? What do we get? A cannot be less than 1.
Yeah.
So, this shows therefore, a cannot be less than 1.
Yes.
So, what happens if a greater than 1? So, can any one of you
Yeah,
try?
I'll try now.
Yeah, try.
So, let me check if a can be greater than 1.
Yes.
So, 10 minus c power a minus 1 is nothing but a c power a squared minus 1. We have
Yes.
already shown.
Yes.
Yeah.
Since a is strictly greater than 1, this is strictly greater than c power a squared minus 1.
Yes.
Again, since a is greater than 1, this can be written as greater than c power a minus 1.
Yeah.
So, this is strictly greater than 10 minus c power a minus 1. Again, we are getting the 10 minus c power a minus 1 is strictly greater than 10 minus c power a minus 1. So,
Which
this
is
is
not-
again not possible. So, either a is equal to 0 or a is equal to 1 are the only possibilities.
Yeah.
So, the only real solutions to this problem,
Original problem.
yeah, to the original problem is x is equal to 0 or x is equal to 1.
1.
Yeah.
Fine. That's right.
That last step, I think that c power a minus 1 is greater than 10 minus c power a minus 1. This will be if and only if c is greater than 10 minus c, right?
Yeah.
So, that means c is 2c must be greater than 10 or c must be greater than 5.
Yes, of course. Our C is such that it lies between 5 and 7, and therefore, C is greater than 10 minus C.
Yes.
And therefore, this is correct.
Yeah.
Of
Hey,
course.
Susmati, you remember that question that was asked in the quiz?
Which one?
That x powered y and y powered x, you have to find the minimum.
Yeah.
I now think that this
What's the problem? Just write down the problem.
the problem was this, that I have to find the minimum value of x powered y plus y powered x,
Yeah.
where
Ah.
x and y are non-negative.
Okay. So, this was one of the questions in the
Yes,
quiz.
ma'am. Yes.
Ah.
And we weren't able to
Yeah, like
do much with the problem.
we could only show that any one of them is bigger than 1,
Okay.
then this should be bigger than 1.
Okay,
But,
fine.
and we got some partial marks, but we couldn't finish. But I guess we have to use some Rolle's theorem like
Or mean
things.
value theorem. Okay. I'll give you a clue.
Okay.
And I will also give you a function with which you should start,
Okay.
so that you will be successful.
Okay,
Yeah,
ma'am.
let's clean the board and see how it works.
Yeah, sure.
So the question was find the minimum of x power y plus y power x,
Okay,
where x and y are both positive numbers.
okay.
One thing is clear, since x and y are both positive, x power y plus y power x should be strictly greater than 0.
Okay.
This is obvious. And one more thing is, if either x or y, x greater than 1 or y greater than 1, if one of them is greater than 1, we can see that x power y plus y power x should be greater than 1.
Okay.
Yes.
Then we couldn't proceed.
What if x and y lie between 0 and 1?
Yeah, so there we don't know how to proceed with
So
that.
you were given some partial marks
Yeah.
for giving this answer.
Yeah.
Okay, let us see what happens if x and y are such that 0 less than x less than 1 and 0 less than y less than 1.
Okay.
So let us look at, say, A, which is 1 minus x, and B, which is 1 minus y.
Okay.
Right, then 0 less than a b less than 1,
Yes.
all right. So now you consider this function f of t, 1 minus a t to the power of b, both a and b are positive and less than 1, and I consider the function f of t, which is 1 minus a t to the power of b, where t lies between 0 and 1.
Okay.
Is this clue enough?
Yeah, I think
Just see.
Using the mean value theorem we can proceed from here.
Okay,
Let me try.
try what happens.
So I have f of t is equal to 1 minus a t to the power of b, 0 less than t less than 1. So by the mean value theorem there exists a t naught in the interval 0 1 such that f dash of t naught is equal to f of 1 minus f of 0 by 1 minus 0.
Fine.
So f dash of t naught will be b into 1 minus a t naught into minus a. Yes. So this is nothing but minus ab
To the power of
Power
b
to
minus
minus
1.
to the power of b minus 1, a minus ab into 1 minus a t naught power b minus 1. This is my f dash of t naught,
Fine.
and f of 1 minus f of 0 by 1 will be f of 1 is
1 minus
a power b,
Correct.
f of 0 is 1
Correct.
divided by 1. So I have 1 minus a power b, both this and this are equal, so 1 minus a power b is equal to 1 minus ab into 1 minus a t naught power b minus 1. So this is nothing but 1 minus ab by 1 minus a t naught power 1 minus b. Again 1 minus b is positive because a and b are between
0
and 1, and then so this is strictly less than 1 minus ab.
Fine.
Yeah.
Okay.
Right.
Okay. I think now I have a clue.
Yeah. Okay. Continue
So
and proceed.
now if we take our original problem that x power y plus y power x,
Yes.
that I can actually write as 1 minus a power
1 minus b.
plus 1 minus b power 1 minus a.
Correct. Yes, sir.
Now this can be written as 1 minus a by 1 minus a power b
Fine.
Yes.
plus 1 minus b by 1 minus b power a.
Correct.
Now this inequality is saying 1 minus a power b is less than 1 by 1 minus ab.
Yeah.
So this must be bigger than 1 minus a by 1 minus ab.
Yes.
Right.
Similarly, if I alter the role of b and a, because both are 0 to 1, so it will be 1 minus b by 1 minus ab.
Yeah.
Yes.
Hence, this should be equal 1 minus, so this is 1 minus a minus b, sorry 2 minus a minus b by 1 minus ab.
Yes.
This I can write as 1 minus a minus b minus 1 minus ab plus ab and plus 1 by 1 minus ab, yeah, 1 minus a 1 minus, so I will take plus here, I will take minus here. So, this I can write as 1 minus a into 1 minus b plus 1 minus ab by 1 minus ab. Hence, the first term it will be 1 plus 1 minus a 1 minus b by 1 minus ab. Now, this 1 minus a is positive, 1 minus b is positive,
Yes.
1 minus ab is positive,
Yes.
hence this quantity is positive.
Yes.
So, this should be strictly greater than 1.
Fine. So, what is it that you have shown?
So, that means x powered y plus y powered x is strictly bigger than 1 for 0 less than x less than 1 and 0 less than y less than 1 also. And other case also we showed earlier that anyone, if any one of them is bigger than equal 1, then the greater than 1.
Yes.
Fine.
So, it
So
is
you are-
always bigger than 1.
Okay, it's always bigger than 1. You are asked to find the minimum of x power y plus y power x for x y positive.
Yeah.
So, suppose I fix my x in the interval 0 to 1, say x is equal to half,
Okay.
Okay.
and I take y to 10 to 0.
Okay.
Then the second term approaches 0
Yes.
and the first term approaches 1.
One.
Yeah.
Right, and therefore since both x and y are positive,
So, the minimum
you can
should be-
conclude that
Yeah.
the infimum of,
yeah, infimum
of
should
the
be-
set of numbers x power y plus y power x for x y greater than 0 is 1,
Yeah.
Yeah.
Yes, yes.
and this is what you were asked to show, right. So, you have to choose this function f of t, that is where everything lies,
Yeah.
isn't it?
Yes, ma'am.
Okay, all right.
Yeah.
So, now we have discussed I mean several applications of mean value theorem and Rolle's theorem.
Yeah.
Yeah.
I think we stop our discussions on these at this stage and then move on to my question about do you have a function f of x whose rate of change is itself.
Okay, okay.
We will discuss it.
Okay, ma'am.
Fine.